There's one thing that's troubled me for many years. Something that sounds so simple. No one even bothers to think about it. But when you shine physics on it, it turns into a question that cuts right through intuition. Imagine this, about 65 million light years away, somewhere in the Virgo Cluster, there's a civilization advanced enough to build a telescope, powerful enough to see Earth's coastlines in detail. No magic, no science fiction, just physics pushed to its limits. And now imagine that being pointing their lens toward our planet. They don't see cities, they don't see satellites, they don't see humans walking on the surface. They're looking through space, but what they see doesn't belong to our year 2026. They see ancient jungles, they see valleys thick with ferns, they see a 4-meter tall, multi-ton T-Rex roaring in what we now call Montana. And that's when the uncomfortable question arises. Are dinosaurs existing right now? You and I both know they went extinct 66 million years ago. But to that alien, they're walking, breathing, hunting, all of it happening in their present. So who's right? And why does a view from so far away shatter our entire sense of time? To answer that, we have to dismantle our intuition and look at the world through the eyes of light, something that never lies, but also never bends to how we want things to be. If an alien can make you doubt the concept of the present, light will decisively shatter the rest. You never perceive time directly. No one does. The only thing you ever receive from the world is light, and light takes time to reach you. Its speed, according to Codata 2018, is 299,792,458 meters per second, a number that sounds infinite, but isn't infinite at all. And it's this tiny finiteness that wrecks our entire intuition. Take the simplest example. Hold up your hand. When you look at it, the light reflecting off your skin takes about 1 nanosecond, 1/1000th of a second, to reach your eyes. That means you've never seen your hand right now. It's always a tiny bit in the past, so small your brain doesn't notice. The problem gets serious as distance increases. When Americans look at the sun, they're seeing an image of it from 8 minutes and 20 seconds ago. The distance from Earth to the sun is 149.6 million kilometers, and light has to cross that entire distance before it hits your eyes. If the sun vanished right this instant, you'd still have more than 8 minutes to sip your morning coffee before you found out what happened. And if even your hand 50 centimeters away isn't appearing now, have we ever seen the present? No mutt. We live on outdated scraps of information that light delivers. So if everything we see is delayed news, then where exactly is this thing called the present? And more importantly, does it even exist the way we think it does? And to see how far this story takes us, we have to go back nearly 4 centuries, to Europe in 1676, a time when people were absolutely certain of one seemingly obvious thing: light travels instantaneously. They believed it not because they were lazy thinkers, but because no one had ever seen light travel. It just appeared. Open a door, the room lights up. Light a candle, darkness vanishes instantly. Aristotle believed it was instantaneous. Descartes did too. And in an era when philosophy still dominated over science, that was pretty much the default truth. Yet in that context, a Danish man named Olaus Rømer did something astonishing. He proved light has a speed, and more importantly, that speed is not infinite. What's remarkable is that he didn't have lasers, atomic clocks, GPS satellites, or any modern equipment. All he had were his eyes, his mind, and a telescope crude by today's standards. Rømer worked at the Paris Observatory under the famous astronomer Giovanni Cassini. His task was to observe Jupiter's moons, especially Io, the one with the most clockwork-like orbit. Io takes about 42.5 hours to complete one orbit around Jupiter. It was so regular people treated it like a cosmic clock. But then Römer noticed something strange. Io appeared late, when Earth was farther from Jupiter in its orbit, and early when Earth was closer. At first the difference was just a few seconds, but over time it accumulated into tens of seconds, then minutes. If you were a 17th century astronomer, this was extremely disturbing, because Io had to obey perfect celestial mechanics. If its orbit was truly changing, all contemporary astronomy would collapse. But Io wasn't changing. Jupiter wasn't changing. So what was? Römer realized something no one before him had dared to assert. The news about Io was arriving late. It wasn't Io behaving erratically. It was that light, carrying its image, had to travel a longer path when Earth was farther away, and a shorter one when closer. Light takes time. News takes time. We always see events later than when they actually happened. From Io's late appearances, Römer calculated that light needed an extra 22 minutes to cross the diameter of Earth's orbit, equivalent to about 300 million kilometers. From that he derived the speed of light around 220,000 kilometers per s. The number was lower than the modern value 299,792 kilometers per for the 17th century, where no one believed light had a speed at all. It was revolutionary. And remember, no one before him had done it. No one had measured it. No one had asserted it. No one had even considered light might be slow. When Römer announced his results, Europe split into two camps. Supporters, this explains everything. Opponents, this insults natural philosophy. But science, as usual, sided with the one who was right. In 1728, James Bradley confirmed the speed of light via stellar aberration. In the 19th century, Fizeau and Foucault measured it more precisely in the lab, but all of them were just drumming along to the tune Römer had first played. He was the one who opened the door, and from there, a series of terrifying questions emerged. If light has a speed, what happens when we move? If light takes time to travel, is there an absolute present? If images always arrive late, do we ever see the world as it truly is? Can you imagine the philosophical fallout of this in the 17th century? The entire classical cosmology was built on the intuition that information arrives instantly. Römer was the first to stand up and say, "No, not that fast," and that seemingly simple discovery paved the way for Einstein more than 2 centuries later. When Einstein wrote his 1905 paper on light, the foundation of special relativity, he built on one of science's most shocking assumptions. The speed of light is not only finite, but an absolute constant in every reference frame. What Römer discovered was the spark. Einstein turned that spark into an explosion that blew apart all of humanity's intuition. Once you grasp Römer's first punch, that light has a speed and news always arrives late, you start to realize a much more uncomfortable truth. Everything you see is a delayed version of the universe. Not sometimes, not in special cases, always. Let's start small to avoid a headache too soon. When you look at the moon, reflected light takes 1.28 seconds to reach Earth. That means every time you gaze at the moon, you're seeing an image from over a second ago. No one complains because the moon still looks the same. But that's just warm-up. To the nearest star, Alpha Centauri, light takes 4.37 years to get here. If American democracy collapsed tomorrow, hopefully not, people on a planet around Alpha Centauri wouldn't know until 2029. Likewise, if they sent you a Christmas card photo, you'd wait over 4 years to see it. And by the time you replied, they'd wait another 4 years. Any dialogue between civilizations at that distance would be a disaster for long-term relationships. But we haven't reached the scariest part yet. Look at Andromeda our nearest large galaxy. Light from there takes 2.5 million years to reach your eyes. When you see it tonight, you're looking at a sky from the time of Homo habilis, early humans still smashing rocks together in Africa. Every time you look up and say, "Oh, beautiful," you're praising a prehistoric scene. And now the part that really unsettles you. If the sun exploded this very moment, Earth would still look completely normal for 8 minutes and 20 seconds. The sky would stay blue. Sunlight would still feel warm on your skin. Gravity would keep Earth spinning as usual. No sign whatsoever that disaster had struck, because the light and information about it haven't arrived yet. You'd have more than 8 minutes living in the illusion of order before darkness suddenly swallowed the sky and everything started sliding out of orbit. And that's when you realize a disturbing truth. You've never seen the sun in the present. Not once in your life. But there are even deeper layers. Let's bring it to everyday American life for clarity. Watching a baseball game. When you see the bat hit the ball, the actual event happened dozens of nanoseconds earlier. The ball leaves the bat, and light takes time to tell you about it. On the Los Angeles freeway, you brake when you see the car ahead's brake lights. But the light from those lights takes billionths of a second to reach your eyes. Then your brain takes another fraction of a second to react. Rushing in the morning, you stand at the microwave, watching the plate spin, but the image in your eyes is an extremely recent past version of it. You live in a life of constant delayed imagery, to the point that if a device displayed your eyes' actual nanosecond lag, you'd probably go insane watching the numbers jump. And back to the cosmos, no distance is small enough for light to be instantaneous, and no distance is large enough for human intuition to stay accurate. We're swimming in an ocean of information, arriving at different delays, and our brains pretend it's all synchronized. But in reality, there's no common present, no moment where everything in the universe is synchronized the way you imagine. Every point in space has its own separate timeline, delayed by the distance between you and it. So write this important phrase on the board that most people never think about. Time lag reality, delayed reality. That's where you've lived since the day you were born. The world you see isn't the world as it's happening. It's the world as it already happened, delivered late by light. And once you accept this, you'll understand why dinosaurs can still be alive to an alien in Virgo, and why no one has truly seen now. And if you want to understand why the aliens present in Virgo can contain dinosaurs, you have to face a truth human intuition hates bitterly. Start with the most familiar, Newtonian velocity addition. You're standing by the railroad tracks. A train passes at 100 miles per hour. Someone on the train throws a ball forward at 100 miles per hour. Result, a ground observer sees the ball going 200 miles per hour. Clean, neat, sensible. Newton nods. You nod. Kids nod. Even your dog probably thinks it's reasonable. But light, as it loves to do, looks at all this and says, no, I don't work that way. If a ship is moving at half the speed of light and you turn on a flashlight forward, do you think the light gets added to the ship's speed? Intuition says yes, but the universe says no. Light still leaves your flashlight at 299,792,458 m per s, and the roadside observer measures exactly the same number. No addition, no subtraction, no exceptions. This isn't minor. This is a hard slap to your entire intuition. The intuition that made us believe everything in motion follows the same rules, but light is different. And if you think this is just theory, let me tell you about an experiment that smashed 19th century belief. In 1887, two American physicists, Albert A. Michelson and Edward Morley, set out to measure changes in light speed as Earth moved through the supposed ether, the hypothetical medium light was thought to travel through. They used an extremely sensitive interferometer capable of detecting shifts smaller than 1 part in a million. And the result? No change at all. No ether. No difference by direction. No velocity addition. Nothing. Light travels at the same speed, no matter how Earth is moving. The Michelson-Morley experiment is called a failure, but it was actually a spectacular success. It demolished the Newtonian model in electromagnetism and cleared the path for one of the boldest ideas in physics history. That's when Einstein, the 26-year-old patent clerk in 1905, stepped in and said, okay, if light speed doesn't change, then what has to change is time and space. A statement that made contemporaries almost laugh, then cry when they realized he was right. And here's the key point. Einstein didn't choose light as the standard because he liked it. He chose it because the universe gave him no other choice. The speed of light is one of the rare things in the physical world that stands still, unchanging for anyone, in any circumstance. From there, the notion of synchronized time collapses. The notion of a common present for everyone collapses. And most importantly, human intuition, evolved to throw rocks and run from tigers, loses completely when it steps into the world of light. To understand what comes next, just remember one sentence, that if I could engrave it on the ceiling of every lab, I would. When your intuition argues with physics, intuition loses. So after you've seen it with your own eyes, well, not eyes, but with your imagination, that light refuses to play by the familiar rules of velocity addition, the natural next question pops up. Why? Why is light so stubbornly weird about this? And to answer that, we have to go back to 1905. The year history of physics calls the Annus Mirabilis Einstein's miracle year. In a single year, while still a patent clerk in Bern, he wrote 4 papers that changed all of modern science. One of them contained 2 propositions, so simple you could scribble them on a napkin over coffee, yet so powerful they completely broke Newton's framework of space and time. 1, the laws of physics are the same in all inertial reference frames. The speed of light in vacuum is constant independent of the motion of the source or the observer. Plainly put, whether you're running toward the light, running away from it, hanging out on a spaceship, or sitting still drinking tea, you still measure 299,792,458 m per s. Not faster, not slower, not pretty much, exactly that. And light doesn't care about your feelings on the matter. This isn't a choice. It's not a nice assumption to make the math easier. It's what every experiment on Earth, from Michelson, Morley to modern measurements, has confirmed. Light holds its speed like an absolute empire. But when you fix one thing, other things have to change to compensate. If the speed of light is fixed, then Newtonian physics, which relies on velocity addition, immediately collapses. If you can't change light, what can change? Einstein looked at the blackboard and answered with an idea so bold that people of his time thought he'd lost his mind. Space and time must stretch and contract to keep light always at its correct speed. Pause for a second to feel how audacious this is. Instead of saying light speeds up or slows down, depending on the observer, Einstein said, no, light stays the same. It's you who change. Your clocks, your rulers, your perception of distance and time. And this idea that you change is beautifully captured in the equations that Hendrik Lorentz had written before. Einstein, the Lorentz transformation, a set of formulas showing that time slows down and lengths contract when something moves close to the speed of light. If you want to keep the speed of light constant in every reference frame, you have to accept the Lorentz equations. There's no other choice. They're not something you believe in or not. They have to be true if the speed of light is true. Take an example to see how bizarre this distortion is. Suppose you're chasing a beam of light at 99% the speed of light. By Newtonian intuition, you'd think I'm catching up to it. But Einstein says nope. You still see it pulling away from you at exactly 299,792,458 m/s. So how does that even make sense? The answer lies in Lorentz. Your time slows down compared to someone at rest. Distances in the direction of motion contract. Every tick of your clock gets adjusted to ensure light always keeps its exact speed in your frame. You know what that means. It means if two people are moving differently, they'll measure time differently. They'll measure lengths differently. They won't agree on whether two events happened at the same time or not. Simultaneous, a concept you thought was obvious, turns out to be just an intuition trick. Time, once seen as the steady flow of cosmic progression, is no longer the uniform stream you imagined. It becomes elastic, bendable, squeezable, stretchable according to velocity. Space is the same. 1 meter is no longer absolute. It becomes something that changes with the observer. Imagine you're sitting drinking coffee in New York, and a friend is flying around Earth near the speed of light. When they return, they're younger than you. Not psychologically younger. Their biological clocks have literally run slower. This isn't science fiction. It's been confirmed multiple times with atomic clocks on airplanes in 1971. Time really does slow down. This is exactly what Einstein forced us to accept. If you want to keep light fixed, you have to sacrifice human intuition. You can't have both. So if time can be bent to accommodate the speed of light, the next question isn't does time change, but how does it change in the real world? And the answer, as always in physics, doesn't come from philosophy or imagination, but from things you can measure. And the simplest way to see time bending itself to velocity is to look at things that don't give a damn about human philosophy. Cosmic ray muons. Muons are created high in the atmosphere, tens of kilometers above the ground, and their normal lifetime at rest is only about 2.2 microseconds. That's 2.2 millionths of a second. Short enough that you'd blink and they'd be gone. If you use classical math to predict, you'd conclude muons could never live long enough to reach the ground. Even moving near the speed of light, they'd still die in midair. Yet they do reach the ground. Not rarely. They do it constantly, in such numbers that no physicist doubts it anymore. And the reason isn't that muons try harder to live longer. It's that their own time flows slower compared to ours on the ground. In the muon's reference frame, it still lives exactly 2.2 microseconds. But in our frame, its time is stretched, making its lifetime dozens of times longer. This seemingly simple story is a direct slap to our entire intuition about time. If a subatomic particle can live longer just by moving fast, then the ticking of time isn't fixed. It depends on velocity. It's elastic, it's soft, and if you want proof involving humans, don't worry, the experiment exists. In 1971, physicists Joseph Hathaway and Richard Keating put atomic clocks on commercial flights circling Earth. Some clocks flew with Earth's rotation, some against it. When they brought all the clocks back and compared them, the results were so clear no one could deny them. Time on the plains flowed at different rates than time on ground clocks. Faster in one direction, slower in the other, exactly as Einstein predicted in 1905. Not approximately, not seems right, but right down to the microsecond. And if you think this only happens in labs, open your phone. The GPS system works because the clocks on satellites orbiting Earth at over 14,000 kilometers per h must be corrected daily for time dilation. If you ignore it, just overlook about 38 microseconds per day, GPS would be off by kilometers. That means relativity isn't just correct on paper. It's secretly adjusting time in your pocket 24/7. And you don't even realize you're relying on Einstein to find your way to Starbucks. All of this leads to one single point. If the speed of light must be invariant, then time cannot be invariant. That change isn't a bug, isn't a quirk. isn't something weird. It's a necessary consequence. The universe can't keep light at constant speed without stretching time, depending on the observer. But time can't change alone. When time stretches, space, the length in the direction of motion, must also contract. That's what the Lorentz equations make crystal clear. The faster you go, the shorter lengths become in your direction of travel. Your 1 meter isn't someone else's 1 meter if you're moving differently. Sounds insane. Every experiment confirms it. And the most beautiful thing about physics is you don't have to believe it. You just have to measure it. Whether you like it or not, you live longer when moving fast. Clocks still run slower on planes. GPS still needs Einstein to work. Time still dilates. Length still contract. Space and time, two things you once thought were separate, are actually a single fabric that can be stretched, distorted, twisted according to velocity. And this is where the story becomes truly important for what comes next. If time depends on your motion, then your present is no longer the same as anyone else's present. Two people moving differently will have two different slices of time, two different versions of reality. And that opens the door to one of the strangest ideas physics has ever produced, the idea that there is no single now for the entire universe, and that what you call the present is just your viewpoint on the space-time fabric. Once you start accepting that time can dilate, lengths can contract, and the present is no longer absolute, you've reached the boundary where a revolutionary statement awaits, one made in 1908 by Einstein's former teacher, Hermann Minkowski. And Minkowski didn't mince words. He stood before a hall full of Europe's finest minds and declared henceforth space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality. A hammer-blow sentence that smashed 2,000 years of human conception. From Aristotle to Newton, time and space were seen as two independent pillars. Space the stage, time the clock. Minkowski said wrong. They're one. And he wasn't just saying it for fun. He had the math to prove it, the geometry to illustrate it, and an entirely new intuition that perfectly fit the special relativity Einstein had published 3 years earlier. Minkowski understood what few dared think at the time. If time changes with velocity, and distance changes with velocity, then space and time cannot be independent quantities. They must be two dimensions of the same structure, a four-dimensional fabric on which every event in the universe sits. Imagine we have our familiar three spatial dimensions: length, width, height. Minkowski adds one more: time, and fuses them all into a 4D coordinate system called spacetime. In spacetime, every event from you blinking to a star exploding 1 billion years ago has a fixed position, 3 spatial coordinates, and 1 time coordinate. No more "this is where it happened," or "this is when it happened," but this is its space-time coordinate. Minkowski didn't just describe this in words. He gave physicists a geometric tool that left them stunned: the Minkowski diagram, where the horizontal axis is space, the vertical is time, and diagonal lines represent the paths of light. Everything must lie within the light cone, where light is the ultimate boundary of information speed. This diagram isn't just pretty. It's the only way to visualize relativity without getting a headache. In that diagram, the motion of an object isn't a path in space, but a world line, a curve connecting the entire history of that object in space-time. You're not just here. You have a line stretching from your birth to your death. The sun isn't just there. It has a 4.6 billion year world line. Similarly, a T-Rex isn't gone. Its world line is still in space-time. You just don't slice through the time where it exists. The key point is this means the idea of now no longer applies to the whole universe, and the Minkowski diagram is the first tool to show this clearly. Imagine slicing space-time, like cutting a loaf of bread with a knife. Each slice is a surface of simultaneity, what you call the present. If you're at rest, your slice is vertical. But if you're moving, the slice tilts. And that tilted slice will contain different events. Maybe my future, your past, or someone else's present, millions of light years away. This is the foundation for one of relativity's strangest consequences. Simultaneity is not absolute. Two events can be simultaneous for you, but not for someone moving fast. An event at the edge of the galaxy might be happening in your time slice, but hasn't happened, or happened long ago in someone else's slice. This sounds like science fiction, but it's a necessary consequence of space-time. When you change velocity, you change the angle of your slice. When you change the angle of your slice, you change the list of events you call happening now. That means two people in two different states of motion can look at the same space-time, but see two different versions of the present. When Minkowski presented this, a young Einstein reacted quite sharply. He's famously said to have quipped, "Since the mathematicians have gotten hold of my theory, I no longer understand it myself." But a few years later, Einstein realized Minkowski was completely right. You can't build general relativity, the theory of gravity, without space-time. Minkowski didn't just explain special relativity. He laid the groundwork for everything that followed, from the Big Bang to black holes, from cosmic expansion to modern cosmological models. And for our story, space-time is the key to understanding the alien seeing dinosaurs paradox. The alien in Virgo is simply slicing space-time at a different angle. If you slice space-time at the corresponding angle, your present could contain a T-Rex, or Napoleon, or humans a million years from now. We're about to get to that part, but first you have to grasp one thing. You don't live in space, and you don't live in time. You live in space-time. And space-time itself, with slices tilted according to motion, will explain why what you think is the past can be someone else's present. Imagine the universe is a giant sausage. Yes, you heard right. A salami, the kind you can buy at any American supermarket. Space-time is that sausage, stretching from the distant past to the distant future, and you only see the present by cutting a slice. Cut straight down with a vertical knife, you get a nice round slice. Tilt the knife a bit, you get an elliptical slice. And the crucial point here is each way of cutting puts you into a completely different present. See how it works. You're standing still on the ground. In your reference frame, your slice into the space-time sausage is a perfectly vertical cut. It passes through the event you're experiencing. For example, you're sitting there reading or listening to me, and through events simultaneous with you in the way you understand now. But remember, your time only flows slower or faster according to your velocity, and your time slice tilts or stays straight according to your velocity too. So imagine you start moving, running, driving, rocketing, or just drifting gently in a spaceship. Instantly your time slice tilts. Not tilting in space, but tilting in space-time. When it tilts, it cuts through different parts of the sausage. That means you start calling different events happening now. This sounds bizarre, but the Minkowski diagram shows it plain as day. Simultaneity is relative. Someone at rest cuts space-time with a vertical line. Someone moving cuts space-time with a diagonal line. And this isn't an abstract example. It's the nature of the universe. Try picturing a very simple one. You and I are standing next to each other, and we agree that now is the moment we both raise our hands. In the space-time diagram, these are 2 points on the same vertical slice. But if an astronaut is zooming past us at 0.8 times the speed of light, their present slice is tilted. For them, my hand-raising and your hand-raising are not simultaneous. One will happen before or after the other, depending on their direction of motion. Nothing in the universe is wrong, just different slice angles. And when you increase the distance, this tilting effect becomes mind-blowing. Instead of you and me standing next to each other, imagine two events millions of light years apart. When you're at rest, your slice catches a certain pair of events. But just move a little, a few meters per second, and your tilted slice will cut spacetime at a completely different spot far away. That means you'll call different events millions of light years distant your present. This is exactly the key to understanding the alien seeing dinosaurs paradox. The alien in Virgo isn't living in your present. They're cutting spacetime at a different slice because their position and velocity are different. Their slice passes through events on Earth from 66 million years ago. Like a T-Rex roaring in ancient Montana. You say dinosaurs went extinct. They say no, I'm seeing them. Both are correct. It's just that their time slices from two different reference frames are different. To make it clearer, go back to the sausage. I cut the sausage straight down. My slice is round and nice. You tilt the knife a little. Your slice is distorted differently, and the part you see in the sausage isn't the same as the part I see. The sausage doesn't change. Only the cut changes. Space-time doesn't change. Only your present changes, according to your cutting angle. The present isn't objective. It's a viewpoint shaped by your velocity in space-time. And the most important thing you must remember is the present is not a property of the universe. It's a choice of your world line. Nowhere in space-time is there a label saying this is now. There's no central cosmic server sending out time signals. No absolute clock hanging in the sky. Every person, every photon, every spaceship, every alien has their own time slice, defined by their velocity and position. The universe doesn't run on the present. It runs on space-time. You don't really live in time. You live on a world line, and your slice decides which part of the universe you call happening. Someone moving differently will have a different slice, and therefore a different present. This isn't just beautiful, it's brutal, because it completely erases the idea of a shared time that human intuition has relied on throughout history. But it's precisely because of this that we can explain paradoxes that seem impossible. The alien sees dinosaurs. We don't. One person sees two events simultaneous. Another sees them separated by light years. A small motion far away can turn the past into the present or push the present into the future. All because of the tilt angle of the knife when you cut the space-time sausage. Just a tiny bit of movement, really just a tiny bit, can shift your time, sliced by millions of years, far out in the universe. To see this, let's go back to our alien friend in the Virgo Cluster, about 65 million light years from Earth. I want you to remember that number carefully, because it's the main ingredient in the cosmic lever I'm about to explain. That alien is standing still on his planet. When his time slice, the one he calls now, cuts the space-time sausage, it passes through Earth's world line at a point corresponding to the late Cretaceous, where T-Rex is still roaring and stampeding through ancient forests. But now, let's do something really small. So small you'll feel silly doing the math for it. Let the alien ride a bicycle. Yes, no rocket needed, no warp drive, no futuristic tech. Just have him step onto an ordinary bike and start pedaling slowly, a few meters per second. The kind of speed you can easily outrun while jogging in the park. The instant he starts moving, his time slice tilts just a little, very small, negligible in everyday terms. But that slice is stretching all the way out to 65 million light years. And this is where the cosmic lever comes into play. An extremely tiny angle here, when extended across that enormous distance, creates a shift of tens of millions of years in what he calls the present. If before pedaling the alien was seeing a T-Rex walking around, then with just a few meters per second of motion, his new slice could cut space-time at a point corresponding to the Jurassic, or the Triassic, or a time when Earth didn't even have dinosaurs yet. Or the opposite, if he pedals toward Earth, his slice could reach into our planet's future, a future we haven't experienced yet. You might ask, how can just a few meters per second create such a huge effect? The answer lies in a formula, so simple you could write it on a napkin. When Seebeert appears in the denominator, you might think the effect would be tiny. But don't forget D is extremely large, so large that the tiny thing you thought gets crushed by Seebeert gets amplified into a gigantic time shift. This is the cosmic lever. Vast distance acts like a giant lever arm, magnifying any small motion into a massive change in the time slice. Let's plug in numbers for fun. 1 meter per second. 1 meter per second thrust, walking speed, just 1 m per s, and the alien's time slice already shifts by 200 years at Earth's end. If he speeds up a bit, 10 m per s, 50 m plus, he can easily change Earth's present in his slice by millions of years. And now you see the problem. The alien doesn't need advanced technology, no instantaneous travel. He just needs to pedal lightly. The way you bike from home to the supermarket is enough to change the present on a planet 65 million light years away in your time slice. And this is where your intuition screams, no, a few meters per second can't possibly change millions of years. But that's because your intuition is used to soccer fields, living rooms, markets, places where distances are tens of meters. But space-time doesn't play by your ruler. The clearest way to see it, if you tilt the knife while cutting a small sausage, you only slightly change the shape of the slice. But if you tilt the knife while cutting a sausage, as long as the distance from Earth to Virgo, that small tilt becomes a gigantic change at the far end. The universe works exactly like that. The alien in Virgo only tilts his world line by a very small angle, but his space-time slice stretches all the way to Earth, and that shift becomes millions of years. This is something most people never think about. Distance amplifies time. A little motion, a little tilt in the slice stretched across millions of light years, shifted into millions of years of time. And you know what this means? It means the alien in Virgo isn't looking into the past in the literal sci-fi sense. He's looking at a slice of space-time, a perfectly valid slice like yours and mine, but with a different tilt angle. In his slice, Earth is in the late Cretaceous. In your slice, Earth is in 2024. Neither slice is wrong. Neither is more correct. His slice is just cut from a much farther position and tilted by a very small angle, small enough that no one on his planet would notice, but large enough to repaint our Earth's history in his reference frame. And that's why, a very real, non-mystical reason, the alien can see dinosaurs. To him, they're alive. To you, they're extinct. All because he pedaled in the wrong direction. This is the strange beauty of space-time. It doesn't change the way you want. It changes the way you move. And what you call the present, the thing you think is solid and synchronized, is just a byproduct of the world line you're living on. We're going to go even further. So if just a small bike pedal in Virgo is enough to shift Earth's present in the alien space-time slice by hundreds or even millions of years, this leads us to an even more terrifying question. So where exactly is the past? Where is the future? Do they really disappear or not yet exist the way we've always thought? This is where we step into the centuries-long philosophical showdown between two views of time's nature, presentism and eternalism. Two ways of seeing time, each convinced it's right, until modern physics stepped in and flipped the board. Presentism says only the present exists. The past is gone. The future hasn't arrived yet. Only the moment you're living in is real. Everything else is just memory or imagination. This is how you operate in daily life. You believe yesterday morning is over, tomorrow hasn't come, and the only thing that exists is now. It sounds reasonable, easy to understand. Intuition loves it. But eternalism, a view that gains strength with 25th century physics, says all moments in the universe's history exist, just like places in space. The past doesn't vanish. The future isn't empty. Everything lies on the space-time fabric, and what you call the present is just one slice you select along your world line. And here's the amazing part. Relativity doesn't just support eternalism. It practically forces us to accept it. Go back to the alien in Virgo. In his space-time slice, dinosaurs are alive, not metaphorically, not as memory. He literally intersects Earth's world line at a point 66 million years ago. If presentism is true, if the past doesn't exist, then what is this slice of the alien's imagination? Wrong. Physics doesn't work by calling someone else's slice wrong. If space-time is real, then every slice is real from the perspective of the slicer. That means the segment Earth 66 million years ago is still there as a portion of the space-time sausage, not gone, not evaporated, not erased. Your slice just doesn't cut through that part anymore. Similarly, the future, the thing you think doesn't exist yet, is already sitting in space-time, like the rest of the sausage you haven't cut to yet. You don't see it, but not seeing doesn't mean it doesn't exist. The Minkowski diagram makes it clear. Space-time doesn't flow, it just is. Time doesn't flow like a river. It stands still like a giant map. Your world line is like the path you travel on that map. You only see the part you're passing through, but the entire map is still spread out there, motionless, complete. And this perfectly explains the alien paradox. Dinosaurs don't come back to life in the alien slice. They don't return. They simply continue to exist in space-time, in the part of the world line his slice passes through. If you change your world line, your slice changes, and you intersect space-time at a different point. So time doesn't flow from past to future the way you once thought. Instead, you're just moving through space-time, and where you intersect determines what you call now. This sounds very alien, but here's an example to make it familiar. When you look at a Mozart score on paper, the entire piece, from the first note to the last, is there all at once, motionless on the page. But when you listen to the music, you only hear one note at a time. Over time, you don't hear the whole piece simultaneously. You only hear the present slice that your musical progression is cutting through. That's eternalism in Mozart style. The work doesn't flow. You flow through the work. The past doesn't disappear. It's just the notes you've already passed. The future isn't empty. It's just the part of the score you haven't reached yet. And you, the one moving through space-time, only experience your world line one slice at a time. Einstein understood this. When his friend Mikhail Besso died, he wrote in a famous letter, "For those of us who believe in physics, the distinction between past, present, and future is only a stubbornly persistent illusion. This isn't spiritual consolation. It's a direct consequence of space-time. Whether you're at rest, moving, accelerating, your time slice is always changing. And that means your present isn't something real for everyone in the universe. Past and future don't vanish or appear. They're always there. You're just passing through them. Right now, you might want to react. If every moment exists, what about free will? Is the future fixed? Do we still decide our actions? Those are big and reasonable questions, but they don't change the physical fact here. Space-time is a four-dimensional block, and what you call time is just the way you travel through that block. You're not a river flowing past the shore. You don't create the present. You're just passing through a point in that structure. This is the block universe, a view that relativity forces us to accept if we don't want to fall into contradiction. In the block universe, every event sits motionless in space-time, like points on a map. The Big Bang, Earth's formation, the age of dinosaurs, the year you were born, the day the sun goes out, the final moment of civilization, all have their own coordinates in spacetime. No event disappears just because you've passed through it. No event doesn't exist yet, just because you haven't reached it. Everything is there. The entire history of the universe is like a finished book. When you're reading page 50, page 49 doesn't vanish, and page 200 doesn't not exist yet. You just aren't looking at them right now. Physicist Hermann Weyl once put it beautifully. The world simply is. It does not happen. And Einstein, who changed our understanding of time, said the famous line in 1955, while comforting Michele Besso's family, "The distinction between past, present, and future is only a stubbornly persistent illusion, not poetry, not philosophy, but a direct consequence of space-time geometry. If two people moving differently have two different time slices, if the present is not absolute, then it's completely impossible to say only one slice is real. One slice shows T-Rex alive, another shows them extinct. Another shows humans building cities we never dreamed of, and all slices are valid. None is most happening. This is why the block universe becomes unavoidable. If every observer has a different present, then there is no absolute present, only absolute space-time. Go back to the example from earlier. The alien in Virgo, 65 million light years away. In his space-time slice, tilted by his own small motion, Earth's world line is cut at a point corresponding to the Cretaceous. That means in the block universe, dinosaurs are still there as part of the space-time structure, not revived, not returned, not ghosts or illusions. They're there like every other moment. You're cutting space-time at 2024. A future civilization might cut at year 120,000. No slice erases another. The block universe doesn't require you to imagine time travel. It only requires you to accept that time doesn't flow. We flow through time. Time doesn't flow through the universe. It's exactly like listening to a piece of music. The entire piece exists on the paper at once, but you experience it note by note. If you fast forward, you hear future notes early. If you rewind, you hear past notes. But the music doesn't disappear or appear. It just is. The block universe works the same way. When you move through space-time, you're reading the next note of the music. When the alien in Virgo moves, he's reading a different page of the same score. Maybe the page containing T-Rex. The moment you were born, the moment you die, both are in the block universe. You're just traveling from one point to another. For many people, this idea is unsettling because it seems to threaten free will. If every moment exists, are all our decisions pre-written? But that's a question for later. Right now, what you need to see is the block universe isn't philosophy. It's a necessary result of space-time. If space-time is real, then every moment in space-time is real. The past doesn't vanish. The future isn't empty. You just haven't gotten there yet. This brings a strange kind of comfort. Every beautiful moment in your life, the first time you saw the starry sky, the first time you fell in love, the last moment you held someone's hand, is etched in space-time, not erased, not swept away. They exist as part of the grandest architecture the universe has ever written, and that completely changes how you understand the alien in Virgo. He's not looking into the past. He's looking at a part of the block universe that his slice cuts through. You see 2026. He sees minus 66 million. Someone else in the future sees plus 50, 000. And if the block universe really is the architecture of the cosmos, then you can start looking at every historical figure, every creature that ever lived on Earth, in a completely new way, not as stories that have passed, but as different segments of the same space-time tapestry, still there, motionless, waiting for someone's slice to pass through. Let's take two figures with nothing in common to test this idea. T-Rex, the giant beast that ruled the late Cretaceous, from about 68 to 66 million years ago, and Napoleon, who lived from 1769 to 1821, one of the most boldly written names in human history. One species lived tens of millions of years before us. One human lived just a few centuries ago. One roared in ancient forests. One shook Europe with wars and laws. In ordinary intuition, they have nothing in common except belonging to the past. But in space-time, they're strangely alike. Both are fixed world line segments in the block universe. Neither segment disappears. Neither melts into nothingness. Both T-Rex and Napoleon are parts of the space-time structure, just like page 27 and page 142 in the same book. Reading page 142 doesn't tear out page 27. You just aren't looking at it anymore. And likewise, when you live in 2024, you're simply no longer cutting space-time through the T-Rex part or the Napoleon part, but they're still there, complete unchanged, as permanent points on the map of time. This isn't a metaphor. It's a direct consequence of space-time being a four-dimensional block. T-Rex's world line stretches from the point it was born to the point it went extinct. Napoleon's world line stretches from 1769 to 1821. Your world line is still being written along your time axis. All these world lines are engraved into space-time, unedited, unerased, unchanged, just because you've passed through or haven't reached them yet. And here's the key point. Whoever cuts space-time at the right angle will see those events in their present. Go back to the alien in Virgo. If his world line is tilted, so his slice passes through the T-Rex segment of the world line, then T-Rex is his present. If he changes his velocity a little, the slice tilts a little, it might leave the T-Rex era and cut through Napoleon's world line, putting the Battle of Waterloo into his present. From a position tens of millions of light years away, the alien's present could contain a 9-ton beast chasing prey, or an emperor riding through Paris. And the most interesting part, this requires no magic, no time travel, no wormholes, or metaphysical technology. It only requires a different space-time slice angle. An observer with a different velocity, small or large, simply cuts space-time at a different place in the block universe. So what about us? We're also in space-time, at a different slice. We're cutting through our own world line, and therefore we have the illusion of our own present. But there's no reason to believe our present is more special or real than anyone else's. For someone in the distant future, their present is a different slice, possibly containing events you call the future, but for them are everyday. And for you, T-Rex and Napoleon are both past, but that's only because your world line is cutting through 2024. If you change velocity, change reference frame, your slice changes, and you'll call different events now. This very idea pulls you into one of the most beautiful truths of the block universe. Every moment is equal in existence. T-Rex in the late Cretaceous exists. Napoleon in the 19th century exists. You living in the 21st century exists. Humans 20,000 years in the future also exist in the block universe. The difference lies only in where the observer is cutting space-time. And this leads to something many people find hard to accept. An event you call over can be very present to another observer. Not because it comes back, not because it revives, but because it's always there in the block universe. Like a page in the cosmic book. You're on page 2024. The alien in Virgo is on page 66 million years ago. A future civilization might be on page 50,000 years later. No page is more privileged than another. Only the reader is standing somewhere in the book. And likewise, you not seeing T-Rex doesn't mean T-Rex is gone. You not meeting Napoleon doesn't mean his world line was erased. You not seeing the future doesn't mean the future is empty. The block universe contains everything. And when you understand this, you also understand one of the most important pieces of the original paradox. The alien sees dinosaurs, not because he's looking back in time, but because his space-time slice passes through a region of the world line that you left long ago. T-Rex and Napoleon are both there, waiting for some observer's slices to pass through, and you're at a different slice, cutting through your own world line at this moment. This is the block universe. No beginning, middle, end according to your experience, but all events existing like a four-dimensional sculpture. If every moment exists, can you jump from one slice to another faster than light? Can you leap through space-time? Can you exceed the speed of light to see the future or past at will? The answer, and I'm saying this gently, because human intuition is very stubborn, is no, never, not a single loophole, not a single exception. And the reason has nothing to do with the universe not allowing it, or not having enough energy. The reason is much deeper. The speed of light is the protective wall of causal structure, and if you cross it, the entire order of the universe, including logic, memory, history, would collapse. What light protects isn't just the speed limit. It protects the meaning of before and after. Let's start with the most famous paradox in physics, the tachyon paradox. Tachyons are hypothetical particles that move faster than light. Sounds appealing. Who wouldn't want particles that let you send messages across time? But here's the trap. In space-time, if you could send a signal faster than light, there would always exist some observer moving at a different velocity who would see that signal travel backward in time. Not metaphorically, not like looking into the past with a telescope, but a real signal arriving before it was sent. What does that mean? It means you could send a message telling yourself not to send that message. It means you could warn the past about what the future will do, and that very information would prevent the future from happening. It means you would break your own logic. Try this simple scenario. You send a tachyon signal to a friend who's moving fast. In your reference frame, the signal goes from A to B. But in your friend's reference frame, because the space-time slice is tilted, the signal goes from B back to A, literally from the future to the past. When the two of you compare notes, you discover, wait, the message arrived before it was sent. And when that happens, the entire concept of cause and effect collapses. You can't have a universe where effects happen before causes. If you try to send a signal saying don't send this signal, what happens? If you receive it, you won't send it, meaning you won't receive it, meaning you will send it again. The universe falls into an unresolvable logical loop. That's called a causal paradox. And that's why the speed of light limit exists. It's the lock on the door, preventing us from breaking the logic of the universe itself. But if you think the tachyon paradox is messy enough, consider the classic one, the grandfather paradox. If you travel back in time and accidentally or intentionally prevent your grandfather from fathering your parent, then you never existed to go back and do it. Paradox, unsolvable. And the speed of light limit is how space-time ensures that no one, no creature, no technology, no signal can play time travel games and shred causal structure like that. This is why Albert Einstein always emphasized that nothing, no information, no physical influence can propagate faster than light. Not because light is special, but because if anything did exceed it, the concept of time would become meaningless. You might hear this and think, but in the block universe, every moment already exists anyway. Why still need to protect causality? Because the block universe doesn't allow you to move from one slice to another at will. You only have your own world line, and that world line must always stay within the light cone. The light cone defines the set of points you can influence, and the points that can influence you. If you go outside the light cone, meaning faster than light, you step out of the region where causality works properly. You'd collide with regions of spacetime, where after and before are reversed for some observers. You'd create a universe where any two observers couldn't agree on the order of events, not in the relative sense of time-slice tilting, but in a deeper sense. One says A causes B, the other says B causes A. When causality isn't fixed, the universe can't function. No law means anything anymore. No motion remains consistent. No intelligence can exist in such a reality. If you're looking for a beautiful reason, this is the closest. The speed of light isn't the limit of light. It's the limit of causality. The deeper you understand, the more you realize this limit isn't prohibitive. It's protective. Causality is what lets you believe effort leads to results, that the future doesn't reach back to change the past. That memory can't alter reality. That event A happens before B for a physical reason, not just because someone's time slice is tilted. If faster than light were allowed, you could send signals to change your own past. You'd shatter your own world line. You'd make the block universe impossible to sustain. Everything we know about space-time, from muons living longer, clocks on planes running slower, to the alien in Virgo seeing T-Rex, rests on one single foundation. Events in the block universe must obey causality within each light cone. Outside the light cone, causality dies. And if causality dies, physics dies with it. You might have hoped for a more romantic answer, like faster than light is impossible because the universe doesn't have enough energy. But the real reason is much deeper. The universe refuses to allow anything to break its own consistency. You can bend time, you can contract space, you can change your space-time slice just by walking, but exceeding the speed of light, no, because it's not about moving faster. It's about erasing the logical foundation of everything that exists. Every interaction you've ever experienced in life is delayed news. You've never touched the present, even once. This may sound philosophical, but it's pure physics at the smallest scales. Electrons, photons, and electromagnetic fields. Let me pull you from the block universe down to the microscopic level, where every touch, every glance, every warmth is transmitted by slow mail. First, ask a seemingly simple question. What really happens when you touch a table? You imagine your hand makes contact with the tabletop, that atoms in your skin touch atoms in the wood. That contact is the most direct thing possible. But the truth is, there's nothing direct here. The atoms in your hand never touch the atoms in the table. They can't touch. Between them is the electromagnetic force. Your electrons repel the table's electrons, and that force doesn't propagate instantaneously. It travels via photons, tiny packets of energy moving at the speed of light. When you press your hand down, electrons in your hand create a change in the electromagnetic field. That change is sent out as photons. Those photons cross the tiny distance between you and the table, reach the electrons in the table, push them back, and then the table responds by sending photons back. The entire sensation of hardness, heaviness, pushback, it's all just phases of a photon exchange. And because photons have finite speed, however mind-bogglingly fast, every interaction you feel is delayed news. When you place your hand on the table, the signal reaches your brain after it happened. Not a tiny bit, always. You've never felt anything at the exact moment it occurred. You always feel a historical version of it. Even when you tap your finger on the table, with only millimeters of distance, photons still take a finite time to carry the force. You sense the hardness after the signal has traveled, arrived, and been processed. The universe doesn't let you access the present in any absolute sense, because every piece of information needs time to travel. And this isn't just true for touch. It's true for every sense. When you look at something, photons reflected from it take time to reach your eyes, you see the past. When you hear a sound, sound waves take time to travel through air, you hear the past. When you smell something, molecules have to drift to your nose, you smell the past. Even your own thoughts arrive late, because neurons need time to propagate action potentials, a few milliseconds. This leads to a conclusion that's both beautiful and painful. You've never been in the now you thought accompanied you your whole life. Even when you touch your own chest and say, "This is me right now," that feeling is a chain of signals that traveled through photons, electrons, neurons, all carrying delay. You're always living a few hundredths of a second in the past, and you can't do otherwise, because that's how interactions happen in a universe with a finite speed limit. Go back to the touching the table picture. When you press down, the feedback force you feel is electromagnetic, but the electromagnetic field can't adjust instantly. It needs time to change. If you press harder, the table doesn't know immediately. Electrons in your hand change position and state. Photons carry that information outward. The table receives it, sends information back. Only after all those steps does your brain register the feedback. Meaning when you think you're feeling the table now, you're actually feeling the table from a moment ago. You're always late. You're always behind the event. You can't live in the physical present. And that's not a flaw. It's a feature of the universe. Because if information traveled instantly, we'd fall back into the paradoxes from earlier. Cause and effect could reverse. The speed of light doesn't just stop you from running faster. It defines how you interact with everything. Without finite light speed, causal structure couldn't exist. And without causality, you couldn't have any stable experience of reality. But here's the more miraculous part. The block universe tells us every event is fixed in space-time, yet it's precisely the delay of photons that makes us feel them in sequence. The experience of time, the feeling that the present is flowing, doesn't actually come from time flowing. It comes from our brains processing delayed signals and stitching them into a story. You never touch the present, but you always believe you're in it. You always receive past news, but you call it now. The universe gives you a delayed movie reel, and you interpret it as a stream of time. Once you understand that every sensation, every touch, every image is delayed information sent via photons, you can reach an even stronger conclusion that delay doesn't just keep you from ever touching the present. It is what creates history, creates the flow of time, and ultimately creates the consciousness you're using to understand this very universe. Imagine this crazy scenario. If light were instantaneous, if photons could deliver information right away, no delay, no waiting, no propagation time, what would happen? You'd think it would be good. Faster reflexes, clearer information, sharper experience. But the truth is the complete opposite. If light were instantaneous, every point in the universe would know everything, the instant it happened. No distance, no lag, no before and after. And when everything happens at once, there would be no progression, no cause, effect, no story, no history. A universe with instantaneous light couldn't have time in any meaningful sense. It would just be one giant snapshot of everything everywhere, appearing like a blinding white flash. No sequence, no order, no arrow of time. Such a universe couldn't contain physics as we know it. But more importantly, it couldn't contain consciousness, because consciousness, in the proper sense, is the ability to recognize change over time. You know you're alive because you perceive motion, change, the memory of a second ago, differing from the next. But if light were instantaneous, before and after would no longer be distinguishable. No delayed signals, no experience of time flow, no story for the brain to build, no consciousness as we understand it. It's the delay that saves the universe from that chaos, because every piece of information takes time to propagate. Some things happen before and some after. Only because light has finite speed do you see the sky as history unfolding, not as a screen displaying everything at once. Without finite light speed, the Big Bang and galaxy formation wouldn't unfold. They'd just be a static state with no way to tell which part is older or younger. No delay, no history, no evolution, no life. And if no life, certainly no you sitting here listening to me. It's the delay that lets the universe tell its story in sequence. And when the universe has sequence, consciousness evolves to read that sequence like a movie. This is how delay creates the arrow of time. Not because time truly flows. We've seen in the block universe that time is static, but because the brain receives information in slow sequence, and the world interacts at the speed of photons and electromagnetic forces. You receive past news, you compare it to present news, you predict future news. Those three steps happen continuously in the brain, and you call it time passing. But in reality, you're just processing delayed signals. In a very real way, you live in the universe's buffer, the memory buffer that delay creates. Without delay, there'd be no buffer, no processing circuit, no logic of a BC. Delay turns events into a chain into progression, progression into history, history into memory, memory into consciousness. Even statistical physics, the thing that defines entropy and the direction of time, relies on information not being able to propagate instantly. If all information spread instantly, entropy would be meaningless, because entropy is the difference between what you know and what you don't. But if you knew everything instantly, entropy would be zero, and no physical process could evolve. The universe would stand still, no arrow of time, no change, no life. Meaning the speed of light isn't just slow by cosmic standards. It's the foundation of everything that can happen. It's the photographer of history, the editor of time, the conductor of experience. You see lightning before you hear thunder, because sound is slower. You see the sun from 8 minutes ago, because light needs time to cross space. You feel force when touching the table after a tiny interval, because photons have to do their job. The entire experience of flow comes from delays in information transmission. If light were infinitely fast, time wouldn't flow. All events simultaneous, no perception. If light were infinitely slow, no interaction, no connection, no life. The speed of light is the perfect value lying between those two meaningless extremes. Fast enough that the universe doesn't collapse, slow enough that the universe can tell a story. And you sitting in your own space-time slice only exist because that story has structure, order, direction. That's the arrow of time, not the needle on a clock, not memories in your head, but the delay that forces every interaction in the universe to happen in sequence. If the alien 65 million light years from Earth can see T-Rex, can they see humans? Can they see our 2024? Or will they forever look at an Earth full of dinosaurs as if we never existed? And to answer, you just need to apply the very principle we've been discussing from the beginning. Light carries news, and news is always late, with the delay equal to distance divided by the speed of light. Earth is 65 million light years from the alien, meaning light emitted from Earth takes 65 million years to reach where the alien stands. It can't be faster. No shortcuts, no live streaming across the cosmos, no magic to make information outrun photons. So the light arriving at the alien's planet today is light that left Earth 66 million years ago, when T-Rex was strutting around like royalty. No cities, no humans, no internet, no New York, no Tokyo, no Paris, just forests, oceans, giant reptiles, and a completely different planet. That's why the alien seeing T-Rex isn't a paradox. It's not time travel. It's not a special effect. It's the only thing consistent with physics. And here's the part that gives many people a slight chill. The alien won't see us for millions of years to come, because the light carrying images of humans from 2024 still has 65 million years left to travel. If you go outside and take a selfie in Times Square today and somehow send that photo via natural photons, the light reflected off your skin, that light photo will wander through space and only reach the Virgo Cluster around the year 65 billion 2024. And by then, let's be honest, humanity might be extinct or evolved into something else or have left Earth, or Earth might no longer be recognizable. By the time news of us arrives, where the alien stands, our present will certainly have become a thick layer of sediment in the block universe. The alien doesn't see us because they can't, at least not with the light leaving Earth today. And this is a very important point. The alien seeing T-Rex is a physical certainty, but the alien seeing us in the future is uncertain because our future isn't guaranteed. The light of our 2024 is heading toward them, but the humans of 2024 won't still be around when that light arrives. In the block universe, the event year 2024 is a fixed slice, but the alien doesn't intersect that slice for tens of millions of years. What's unique about this story is they can never interact with us in real time, because light never catches up to their present. You might think, but if the alien really wanted to see us, couldn't they just fly a spaceship closer to Earth? Sure, but you're thinking with human intuition, not space-time physics. If they start flying toward Earth, they would catch up on some of the delay. Instead of waiting for light to come to them, they actively move toward the light. But no spaceship moves faster than light, meaning they can't overtake Earth's future news. They can only reach space-time slices that light has already brought information to. Meaning if the alien wants to see the Jurassic, just stand still and wait. If the alien wants to see 2024, they have to wait 65 million years. If the alien wants to see the year 3000, they have to wait 65 million plus 1,000 years. The only way for them to see us sooner would be breaking the laws of physics, pushing signals faster than light, becoming tachyons, piercing the light cone, which we've already seen is impossible because it destroys causality. So this seemingly thrilling paradox turns out to be a brilliant proof of physics unity. If you're 65 million light years away, you'll always see Earth from 65 million years ago. Not earlier, not later, no exceptions. Like this, you look at the moon 1.28 seconds ago. You look at the sun 8 minutes ago. You look at Andromeda 2.5 million years ago. The alien looks at Earth 66 million years ago. None of them is seeing wrong. They're all just seeing the space-time slice that matches their distance. And here's something few people think about. We are also someone else's alien, somewhere far away, looking at Earth's millions of years ago version. Right now, a civilization 200 million light years away might be observing Earth when it was still a glowing red magma ball, because light from that era is only just reaching them. They ask each other, does that hot red planet have life? And they don't know they're looking at baby Earth, because the light of our adult Earth hasn't reached them yet. They see our past. The alien in Virgo sees our past. And another civilization even farther away will see an even deeper past. So will they ever see us? Yes, but not now, not soon, and maybe not while humans still exist to be seen. And this is the beautiful irony of space-time. The alien sees T-Rex clearly and certainly, while whether they see us is completely uncertain. Dinosaurs, extinct for 66 million years, are guaranteed to appear in the alien slice. Humans, alive today, are not guaranteed to exist in the slice, 65 million years from now. The past is certain, the future is not. Once you've seen that the alien in Virgo never truly sees us now, but only Earth from 66 million years ago, you can start to recognize a truth that's even closer to home, quieter, but profound enough to change the way you understand your own life. Even here, right on Earth, you're not synchronized in now with anyone, not with your lover, not with your parents, not with the person sitting next to you, not even with yourself from a billionth of a second ago. We are all tiny aliens, each living in our own private time bubble, a range where light has had time to bring information. Beyond that bubble, everything is either past that hasn't arrived yet, or future you haven't touched. This isn't poetic imagery. This is the light cone, the thing relativity gives us to describe the events you can know, can influence, or will never reach. Imagine you're standing at the center of an invisible sphere whose radius expands at the speed of light, multiplied by the passing time. Inside that sphere is everything you can know right now, because light has had time to travel from there to your eyes. Outside the sphere, the news is still on its way. You just haven't received it yet. Everything you see, hear, touch, comes from the thin shell of that time sphere. And because the sphere keeps expanding at light speed, you're constantly catching up to the universe's news, but never fully catching it. The beautiful thing many people don't realize is each person has their own sphere. Two time bubbles never perfectly overlap, even if you're standing right next to someone. When someone says, "I'm looking at you right now," they're actually looking at you from a few nanoseconds ago. When you hold someone's hand, the force feedback arrives after a tiny delay. Even when you look in the mirror, the image you see is you from the past, negligible in daily habit, but completely real in physics. See the subtlety here. When you say, "I'm seeing you right this moment," that's just your brain simplifying reality. In truth, light from the other person takes a small amount of time to reach your eyes. In that time, they've aged a tiny bit, changed a tiny bit, lived a new slice of space-time. That means every conversation, every touch, every moment in life happens between non-overlapping time bubbles. We never truly meet in an absolute present. We only meet in the intersection of separate light cones. And the wilder truth, even you yourself don't live in a single present. Your brain receives signals from your eyes, slower than from your ears, signals from your feet slower than from your hands, signals from your skin slower than from your retina. Your brain collects all these signals, which arrive at different times, and fabricates a unified present, so you don't go insane from temporal chaos. You don't actually perceive time as it happens. You perceive an edited in post-production version of time. You think you live in a continuous flow, but in reality, you live in a cloud of delayed information, and your brain builds the story. Now I'm alive. Think about the event you just experienced a minute ago. It lies in your past light cone, the region of space-time that can send information to you. The event you'll experience a minute from now lies outside your light cone. Neither you nor the universe has sent news of it to you yet, and the event happening to someone at the other end of Earth, news from them takes about 0.07 seconds to reach you. Meaning when they say, "I'm alive," you see a delayed version of that statement. When you reply, "I'm alive too," they see a delayed version of you. Even when you place your hand on your chest and whisper, "This is me," that sensation comes from a chain of delayed signals. There is no moment when you perceive yourself in an absolute present. You only perceive yourself in the available present, the result of signals that have traveled through electromagnetic fields, photons, and neurons. The world you live in isn't the world as it's happening. It's the world as it's being delivered, nanosecond by nanosecond, photon by photon, light cone overlapping light cone. And here's the strangest part, because each person has their own time bubble. Each person lives in a slightly different universe. No one sees the same sky at the exact same moment. No one feels the same instant with the same delay. No one has the same space-time slice. Each person, in the strict physical sense, has their own version of the universe, not because of different emotions or psychology, but because the information they receive from the universe arrives at different times. This doesn't mean the universe splits into multiple realities. It just means there is no single reality experienced by everyone at the same time. The present is a personal model your brain constructs based on information inside your light cone, and your light cone is never the same as anyone else's. So when the alien in Virgo sees T-Rex and you see the phone in your hand, both of you are correct within your own time bubble. And this leads us to a profound question. If each person lives in their own time bubble, then what holds the universe together into what seems like a unified experience? Why don't we feel this phase difference more clearly? And what makes these time bubbles merge into the shared time we think we're experiencing? If each of us lives in our own separate time bubble, each receiving a slightly different version of the universe, delayed or advanced a bit, depending on distance and how information arrives, then you can start to see an even deeper truth. Humans were not evolved to understand space-time. Not because we're stupid, not because we're lazy thinkers, but because evolution doesn't care about Minkowski space-time. It only cares whether you survive the night in the forest, dodge the tiger, find food, reproduce. None of that requires you to distinguish between space-time slices, light cones, relativity of simultaneity, or understand that the alien in Virgo is viewing a different version of Earth. Our nervous system is designed for quick responses, not absolute accuracy. It doesn't need to know that when you see a tiger charging, you're actually seeing the tiger from 3/millionths of a second ago. It just needs you to run now. And because evolution doesn't need physical precision, it cheats freely, it discards data, it compresses time, it interpolates to create the illusion of a seamless present. The present you believe you're living in is actually a neural fabrication, a thing built with brain tricks, not physics. To see this more clearly, look at how the brain processes signals. When light hits your retina, the signal travels through multiple layers of neurons, the optic nerve, the lateral geniculate nucleus, then to the visual cortex. The whole process takes about 150 milliseconds. When you hear sound, the signal takes a different path and a different time. When touch sensation travels from your finger to your brain, it can take 20-50 milliseconds, depending on location, meaning all your senses arrive at your brain at different times. If the brain did nothing, you'd see the world like a movie with out-of-sync audio, video, and touch sound lagging behind image, touch lagging behind sound, everything fragmented, like a glitched episode. But the brain hates that lag, so it does what evolution is extremely good at. It cheats. The brain waits about 200 milliseconds, the average reaction time, to gather all the signals, synchronize them, and construct the story. This is now that you think is real. This means you always live in a delayed present, a virtual present, not the physical present. When you clap your hands, the image of your hands meeting reaches your brain at time A, the sound at time B, the sensation at time C, and your brain merges all three into a single event, even though they didn't happen simultaneously. This is why visual illusions exist. The brain prefers smoothness over truth. When you look at a static image, but think it's moving, when you see two flashing dots jumping back and forth, and your brain connects them into a curve, when you see a face in the dark, when no one's there, all are examples of you not evolving to see correctly, but to see usefully. Minkowski could see space-time as a 4-day diagram with tilted simultaneity and different slices. Einstein could easily say past, present, and future are a stubbornly persistent illusion. But your brain, optimized over millions of years, running from tigers, sees a flat, three-dimensional world, absolute time, absolute now, everyone sharing the same timeline. For the brain, T-Rex once lived and Napoleon once existed are absolute past, gone forever. It can't imagine that both are still somewhere in the block universe, and the alien just needs the right slice angle to see them alive. And you know what's interesting? That's not a bug. That's a feature of being human. If evolution required you to compute Lorentz transformations to escape a tiger, humans would have gone extinct 200,000 years ago. If evolution required distinguishing presentism from eternalism to find fruit, no one would be here listening to me. Your intuition didn't evolve to understand spacetime. It evolved to survive. But here's the paradoxical and beautiful part. Even though intuition wasn't born to understand spacetime, your intelligence can transcend intuition. Somehow, completely outside evolutionary goals, humans invented mathematics, Minkowski geometry, light cones, relativity, and from that peeled reality away from evolutionary illusion. You may not feel that each person lives in a different time bubble, but you can know it. You may not intuitively grasp that the alien is seeing T-Rex in his slice, but you can calculate it. You may not sense the block universe, but you can comprehend it. And this is one of the wonders of human intelligence. We evolved to survive in the jungle, yet we have the capacity to understand the nature of space-time, something no creature in the jungle ever needed to know. The nervous system didn't evolve to understand the universe, but your intelligence goes beyond evolutionary goals. And that very ability to transcend, to escape limited intuition, to escape the illusion of time, is what lets you see the universe, not as it appears, but as it truly is. So why can humans, a creature living on a rock, orbiting an ordinary star, understand space-time? Why can a 1.4 kilograms lump of soft tofu-like meat, bathed in salty fluid, optimized only to flee predators and find fruit, see through the structure of a 93 billion light-year wide universe? No lion understands space-time. No whale understands relativity. No chimpanzee writes Maxwell's equations. Yet you, a descendant of creatures that once bit wild fruit and climbed trees, can understand that time is not absolute, that light is the limit of causality, that the alien in Virgo can truly see T-Rex, and that you live in one slice of a four-dimensional space-time fabric. If that doesn't make you feel wondrous, I don't know what will. Look back at the absurd yet beautiful journey humanity has taken. In 1687, Isaac Newton published Philosophiae Naturalis Principia Mathematica. He had no supercomputers, no modern telescopes, no particle detectors, no fancy labs, just intelligence, paper quill, and an apple falling on his head. Yet Newton built a mathematical framework that could predict planetary orbits, falling objects, tides, the entire material world. Before Newton, motion was chaos. After Newton, motion became equations. And simply by understanding motion, he laid the first stone on the path to space-time. Then in 1865, a quiet Scotsman named James Clerk Maxwell wrote 4 equations, just 4. But those 4 equations, the Maxwell equations, unified electricity and magnetism into a single field, and somehow made light emerge, not as magic, but as the inevitable consequence of oscillating electromagnetic fields. Maxwell had no intention of creating relativity or space-time. He just wanted to understand electricity and magnetism. But his equations secretly contained a terrifying truth. Light has a fixed speed, independent of the source, independent of the observer. It sat in the math like a sleeping wild beast, waiting to be awakened. And then in 1905, a Swiss patent office clerk named Albert Einstein, who commuted in worn-out shoes, and whose former teacher said he had no future in physics, woke that beast. With a 30-page paper, no experiments, no lab, no funding, Einstein wrote on the electrodynamics of moving bodies, the birth of special relativity. Based on just two postulates, the laws of physics are the same in all inertial frames, and the speed of light is invariant. Einstein blew apart all of humanity's intuition. He made time dilate. He made lengths contract. He made simultaneity relative. And he took space and time, two entities humans once saw as independent, and welded them into one spacetime. But he didn't stop there. In 1915, he did what I think is one of the greatest intellectual leaps in human history. He turned gravity, what Newton called an attractive force, into the curvature of spacetime. No strings, no invisible force, no instantaneous action, just spacetime curving and matter following that curve. Suddenly, the universe was no longer a rigid stage. It became a soft fabric, bendable, twistable, wave-like. If you slam hard on that fabric, you create gravitational waves, something humanity took a century to detect, exactly as Einstein predicted. This is a moment worth pondering. A brain born in the jungle, evolved to throw rocks and avoid snakes, came up with the idea of space-time curvature, something that encompasses galaxies, black holes, clusters, vast filaments. A 1.4 kilograms brain could say, I know how the universe works. No animal comes close. Look at what Earth is in the cosmos. A speck orbiting an ordinary G2V star in a middling spiral galaxy, in a universe with over 100 billion galaxies. Nothing here says creatures on this planet must understand light. Nothing says they must know. Time dilates near light speed. Nothing forces them to understand the block universe as a static four-dimensional structure that the alien in Virgo can read differently from them. Yet you do, yet we do, and that, I repeat, is not an evolutionary goal. Intuition is completely wrong about spacetime. Visual reflexes are full of illusions. The brain stitches delayed signals into immediate reality. But human intelligence, the most miraculous thing evolution accidentally produced, has the capacity to go beyond intuition's limits. No need for the strongest body. No need for the longest claws. No need to run the fastest. We just have thought. But that thought is enough to see through the fog. Evolution placed before our eyes. Enough to say space and time are not as we feel them. Enough to see things eyes can't see. Measure things ears can't hear. Understand things beyond the experience of any species that ever lived. Enough to know the universe is space-time, that light is the speed of causality, that time doesn't flow, we flow through time, and strangest of all, enough to realize our smallness and greatness at the same time. Small, because we're just stardust. Great, because stardust can understand the very laws that created it. After traveling the entire journey from light touching your hand to the curvature of space-time, from T-Rex to Napoleon, from each person's light cone to the intellectual leaps of Newton, Maxwell and Einstein, we return to the simple but most storm-causing question from the beginning. Does the alien in Virgo really see dinosaurs? And if so, are they right? And the answer, after everything we've explored, is yes, the alien is right, and you are right too. Both are correct at the same time, even though they're not seeing the same Earth. This sounds like a joke, but this is the beautiful point of the block universe. There is no single Earth happening. There are countless Earths, each slice a different moment, and each observer cuts spacetime at a different slice. You cut the 2024 slice. The alien cuts the minus 66 million slice. A future civilization will cut the plus 120,000 slice. All slices exist on the space-time sausage, and no slice is more real than another. They are just the positions where an observer's world line pierces space-time. Go back to the opening hook. You stand on Earth, look up, and see a sky full of stars. You see light from hundreds, millions of years ago. You accept that. You don't argue that Sirius can't look like 8 BC because it's 2024 now. You know light takes time to travel. The alien in Virgo does the same thing, but on a much larger scale. Light that left Earth in the T-Rex era takes 65 million years to reach his eyes. He's not looking into the past magically. He's just looking at the light that's arriving. And that light carries dinosaurs, not humans. But at the same time, you look at Earth and see humans, not dinosaurs. You're right. He's right. No contradiction. If you try to use intuition to decide who's right, you'll fail, because your intuition wasn't designed to handle space-time. But if you use space-time as the measure, everything becomes transparent. The alien is looking at a different slice of the same block universe, and the universe runs on slices, not intuition. Try a simple image. You're reading a comic book. Page 3 has dinosaurs. Page 84 has humans. If you open page 3, you're seeing dinosaurs. If the alien opens page 3, the alien sees dinosaurs too. If you open page 84, you see humans. No one is wrong. They're just opening different pages. Space-time isn't a comic book, but it's similar in the most important way. All pages exist at once, no matter which page you're reading. This forces you to accept the truth. Einstein once called cruel, past, present, and future are not separate as we imagine. They're just labels the brain sticks on different space-time slices. And that leads to the final question. If there are so many slices, and each person sees their own, then what is truth? This is a subtle philosophical question, but physics answers it bluntly. Truth is the block universe. Every slice is correct in the reference frame of the slicer. If you're at rest, your slice is vertical. If you're moving fast, your slice is tilted. If the alien in Virgo shifts his foot a little, his slice tilts by millions of years. If you look at Andromeda, you see a galaxy 2 million years old. Not because it hasn't changed, but because its light is telling the story of a past slice. And all of this means the universe isn't reasonable according to your intuition, but it's absolutely reasonable according to mathematics. Intuition wants time to be shared. Absolute solid. A river with a clear direction. Mathematics says time is the fourth dimension. Flexible, tilted by velocity. Intuition wants light to add velocities, like a ball thrown on a train. Mathematics says light keeps the same speed in every frame. Intuition wants simultaneity to be obvious. Mathematics says simultaneity is relative. Intuition wants the past to vanish and the future not to exist yet. The block universe says both are always in the space-time structure. So in this battle, who wins? Einstein would smile and say, when intuition argues with mathematics, intuition loses, and you should thank that. Because if the universe ran on human intuition, it would have collapsed long ago. Yet there's one more miraculous thing. Even though our intuition is wrong, we have the ability to understand what's right. A brain born to evade predators can peer through space-time. A body evolved to climb trees can write the Lorentz transformation. A stone thrower from long ago is the ancestor of people today who measure gravitational waves from two black holes colliding billions of years ago. And you, the one reading these lines, can understand that the alien sees dinosaurs, and you see humans not because one is right and the other wrong, but because space-time gives each a different slice. And perhaps this is what I want you to carry with you when the story ends. The universe has no obligation to make sense the way you feel it, but it always makes sense the way it operates. It's not simple, it doesn't cater to you, but it's consistent, beautiful, and deeper than any human imagination. Dinosaurs in the alien slice, humans in your slice. All of it lies in the block universe, peaceful, static, waiting for observers to pass through. And if you look up at the night sky tonight, remember this last thing. You're not looking at the universe as it is. You're looking at the story light is telling you. That story is always late, but miraculously, you have the ability to understand that very lateness, and from it understand the universe. If that's not the most beautiful thing humanity has ever done, then nothing is. If you want to keep exploring the wondrous stories of the universe with me, please subscribe so you don't miss any part. See you in the next journey, where we still have so much to illuminate in this vast sea of space-time.